There we go again. I've decided to make only 2 more episodes of this series of tutorials because the other problems of Project Euler have become so complicated that the interesting part of it is not the implementation but actually finding the idea for the right algorithm to solve the problem. So I would waste a lot of time to explaining that algorithm, and I think this is something which you have more fun finding out yourself, and too little time explaining new Scala stuff. So I've identified 2 more interesting Project Euler problems that we might be able to solve pretty quickly. And the first of them is problem 16. 2 to the power of 15 equals 32,768, and the sum of its digits is 3 plus 2 plus 7 plus 6 plus 8 equals 26. What is the sum of the digits of the number 2 to the power of 1000? So let's switch to the IDE. There we are. Now, obviously, a number as big as 2 to the power of 1000 won't fit into an integer or a long variable. Therefore, we gotta use something like big integer. As you know, in Java, big integer is a class that supports numbers of arbitrary size. You can use the Java big integer in Scala. However, there is another class provided which is called big int, which is basically the same as big integer, but it offers some more Scala goodies, and yeah, that's what I'm going to use. This time and also the next time I won't show you a Java-like solution. You can do this yourself if you wish and then compare the two. I think by now you've seen that the Scala solution is always the shorter one. First of all, we got to create a big int, and I'm going to create a big int from the integer 2 because I cannot write down 2 to the power of 100 just like this. However, it's a pretty nice thing that the big int class provides an exponential method, which unfortunately int and long don't have. Now this is 2 to the power of 1000, and now what we got to do is build a sum of all the digits of the resulting big int. To get the digits, we might get the idea to convert the big int to a string first. So we have a string containing all the digits as characters. And now there's one interesting thing about Scala, which might astound you. In Scala, a string is not only the same as a Java string, but also a sequence of characters. And this means you can call all the sequence methods also on strings. For example, the map method. So what we want to do now is convert every single character of the string to an integer, and that integer is exactly the digit value of that character. Since we're going to use the character only once, I'm using the underscore here to build an anonymous function, a closure, and as you can see, Scala provides for characters the asDigit method, which makes our work here incredibly simple. So now what do we have? Now we don't have a string anymore as a result of the map method, but we do have a sequence of ints. And for that we know what we gotta do. We gotta build the sum, then print out the result, save it, compile. Yeah, it worked. Run the program. 1366. Let's look it up on the web page. There we are. Scroll down. 1366. Back to the IDE. So yeah, that's our solution. What was new in this short little episode is that there's a big int class, and You can use strings as sequences of characters. There's a as-digit method in character. Yeah. And we will use that in the next episode. Until then, bye.